But what we want to do is look at how to solve systems if they're not linear. All the ones that we've done so far are linear. What I want you to do for the first few things here, I just want you to kick back and think. Nothing that I'm going to show you is worth writing in your notes. This is just to give you a perspective about what we're going to try and do. We want to solve nonlinear systems of equations. Now, a couple of notes about this. First of all, we want to do just what that says. We want to solve equations that involve nonlinear systems. Now, we've only had a few nonlinear equations so far, so we're kind of limited as to what we can do. But think about this. Again, don't write any of this down. I just want you to think about these things. First of all the systems that we've had so far, whether you've thought about it or not, all of them have had one solution because they've all boiled down to straight lines. Okay? All the equations that we've done so far, all the equations have been those of straight lines. And straight lines can't cross more than once. Not while they're still being straight, and not while you're graphing on a flat surface. Now, nonlinear graphs, if you have graphs that aren't lines, they can cross many times. Okay? For example, if we had some system of equations that wasn't linear, we could have two graphs that looked like this. There would be one graph, and there was another graph. Now, how many solutions would there be to a system that looked like that when you graphed it? There'd be 4. Every time the two graphs cross, 1, 2, 3, 4, you get another coordinate or another x and y value that would satisfy that system. So what we want to look at today are those types of systems that don't necessarily make straight lines. So we're going to start with some that we're familiar with. Again, don't put this in your notes. I just want you to think about this. Up there I've got two equations, 2x squared plus y equals 5, and 2y equals 1/2 x plus 4. First of all, the top one, 2x squared plus y. We're not going to solve this. All I want you to do is think about what two curves we've got. 2x squared plus y equals 5. Now, you might have to do a little rearranging, but ultimately, what curve is that going to give you? Not a hyperbola. It's going to be a parabola. If you shift that 2x squared to the other side, you will get y equals negative 2x squared plus 5, which you all know to be a parabola. Now, just a little review from a couple of weeks ago, is that parabola going to open up or down? It's going to open down because the leading coefficient is negative. So this is going to be a parabola that opens down. Okay? What about the other one? 2y equals 1/2 x plus 4. What's that going to give you when you graph it? It's going to be a straight line. If you take that second equation and divide every term by 2, we'll get y equals 1/2 x divided by 2 is 1/4 x. Plus 4 divided by 2 is plus 2. Okay? That's going to be a straight line. So now think about this. We're going to have a parabola that opens down, and we're going to have a straight line. Do they necessarily have to cross? Do a parabola that opens down and a straight line necessarily have to cross? No. Could they cross? Sure. Could they cross more than once? Yeah. Could they cross 3 times? No. If you graph both of those, there's what you end up with. You get a parabola that opens down, and if you graph that straight line, as it turns out of poor planning, I graphed those functions in the opposite colors that I wrote their equations in. The parabola opens down, the straight line crosses it 2 times. So we don't care what they are at this point. We'll get to that in a few minutes. But how many solutions will there be to that system of equations? There'd be 2 solutions. Okay? The first thing you should do when you see a system that's not linear is you should ask yourself, about how many solutions could I get? Incidentally, could a parabola and a straight line in a system yield exactly 1 solution? Could they hit exactly once, or is that not possible? They could. If that parabola somehow is such that the straight line just grazes it, that is to say it's tangent at some point, there could be 1 solution, 1 point that's on both, and that would be it. So there could be 0, 1, or 2 solutions when you've got a straight line and a parabola. What are these 2 curves going to be if we graph them? 2x squared plus y equals 5. In fact, that's exactly the same one we just used. So we know the top one is a parabola. And the bottom one, y equals, well, I kind of set that one up for you, didn't I? Y equals negative 2x squared plus 2x plus 4. What's the second one going to be? Going to be a parabola. Now think about what your options are. You've got two parabolas. Think about how many different possibilities or different intersection points you could have for two parabolas. Is it possible that they never cross? It is possible that they never cross. Okay? We could have any number of possibilities. It could look like this, where we could have one open up and one open down. They could never cross. Now, these two, we know that the top one we already established would open down. What about the bottom one? Is that one going to open up or down? Down. So since they both open down, is it possible that they never cross? It is. Even though they both open down, it's still possible. How could it be? One sits inside another one. That's right. And they would never cross. So it's possible that we would have no solutions to this, that they never cross. Is it possible that those two parabolas, both of which open down, could cross once? Yep, that's right. It is possible. It could be the case that they do that business, all right, and cross exactly once. Is it possible that they could cross twice? They both open down. Is it possible for two parabolas that both open down to cross twice? Yep, that's possible. If one of them's wider than the other, this one could look like that. So they could cross twice. Could, going on, is it possible for two parabolas that both open down to cross 3 times? Nope. It's not possible if they both open down. However, it is possible for two parabolas. We've only looked at parabolas so far that open up or down, but it is possible to have parabolas that open side to side. Is there any way that two parabolas could intersect 3 times? Now, if you allow them to open in any direction, either up, right, down, or left, is there any way you can think of where two parabolas would intersect exactly 3 times? They could cross 3 times. They could intersect 3 times. If you had one that looked like that, and another one that looked like that, there they'd intersect 3 times. How about 4 times? Sure. Well, so when we go to solve this system in a minute, we have to be ready for either 0, 1, 2, 3, or 4 solutions. Is it possible for any two parabolas to cross more than 4 times? No, it's not possible, okay? Well, these two particular ones happen to cross exactly 1 time, okay? But if we think about what shapes we've got or what curves we've got before we go and try and solve the system, we're going to kind of have a clue as to what we might be looking for answers, as how many we could come up with. Okay. Now what we're going to do is we're going to solve a couple of systems that aren't linear, keeping these facts in mind. Before we do that, just to summarize, if you've got a system with a line and a quadratic, one line and one quadratic, how many solutions could there be? If you have one line and one quadratic, there could be 2. Will there necessarily be 2? No. If you have a straight line and a quadratic, you'll either have 0, 1, or 2. Because the parabola might not intersect the line at all. The parabola might intersect the line once. Or the parabola might intersect the line twice. Won't ever intersect more than twice. And the other thing we'll summarize before we do some examples is if you have two quadratics. If a system is made of two quadratics, how many solutions might there be? Up to 4. Right, depending on different ways that two parabolas can intersect, and we just worked with that just a minute ago. So let's jump in and do some examples here. Let's solve this. We don't have any new methods. We just use the same methods that we've done before. Y equals x squared, y minus x squared equals -2. And we have 3y minus x equals 4. Now we want to solve by substitution. Would you rather take the top equation or the bottom equation, and would you rather solve for y or for x? There is definitely one good answer here. Top one for y. Is it even a reasonable option to say we could solve the top equation for x? While you could do it, it would be a mess because you're going to have to start taking square roots and this equation is going to get out of control. So the most efficient thing here is to take the top equation and solve for y. And we end up with y equals x squared minus 2. Now we're going to substitute that value down into the bottom equation. And this equation then becomes, let's go down here, 3 times x squared minus 2 minus x equals 4. Now what kind of equation are we going to end up with here? You're going to end up with a quadratic equation. So how many solutions could there be for x here? There could be 2 solutions for x. So if we solve this, we're going to get 3x squared minus 6 minus x equals 4. Rearranging and putting it in the form ax squared plus bx plus c, we get 3x squared minus x minus 10 equals 0. Now let's stop there for a minute. Now we have a quadratic equation. There's 2 different values of x to satisfy this system. Look okay up to there? Okay. How do you want to solve that? We could use quadratic formula. Absolutely. A is 3, B is -1, C is -10. This one does happen to factor. And if you can factor it, that's the fastest method if it does happen to factor. It factors into 3x and x. And the other factors here are 5 and 2. 3x plus 5 times x minus 2 is how it factors. So we've got 2 solutions for x here. This side will give you x equals 2. That factor gives you x equals 2. Or x equals the other one. I'm just going to skip the step of solving it, but we would set that equal to 0 and solve, and we get x equals -5/3. Okay, so those are our 2 solutions for x. Same thing you'd get if you use quadratic formula. Now we're almost done, but we now have 2 solutions. The first one is if x equals 2, so we're going to have 2 ordered pairs here, 2 comma we don't know what, and the other one is going to be -5/3 comma we don't know what, but we got to figure it out. So here, when x equals 2, I'm going to rewrite that. When x equals 2, y equals 2 squared minus 2, which is 2. And so one ordered pair is 2, 2. When x equals 2, y equals 2. When x equals -5/3, we have y equals -5/3 squared minus 2 If you crunch that out, you will end up with 25 over 9 minus 18 over 9, which leaves you with 7 over 9. And our second solution is negative 5/3, 7/9. And there they are. Now we're going to solve the exact same problem, but this time we're going to use elimination. Well, which variable do you want to eliminate, x or y? Y. Do you have any choice? You don't. Why can't you eliminate x's here? They're not the same term. They are not like terms. They can't be combined. We can't take x squareds to cancel off x's, nor can we take x's to cancel off x squareds. We can only cancel off like terms. These are the only two like terms we have, so we have to cancel the y's. So let's leave the bottom equation just as it is. And let's multiply the top equation by times negative 3. We end up with negative 3y plus 3x squared equals 6. Now we can combine those two and the y terms will cancel off. So we end up with, those are gone. Here we've got 3x squared minus x. Common mistake here. Stop there for a second. You might know what the very common mistake that's made when you're using elimination? What? Just subtract it and call this either 2x squared or 2x, but they're not like terms. So all we can do is take 3x squared minus x. That equals 10. Shift everything to one side so it's of the form ax squared plus bx plus c. Is this starting to look familiar? 3x squared minus x minus 10 equals 0. Now, where have we seen that before? About 2 minutes ago. You end up with the same quadratic to solve. Okay, so it doesn't matter what method you use. You're always going to end up cranking out the same thing. Well, we won't go through the whole last half of the process again because at this point it's exactly like the last problem. And so we can say that this, again, would factor into 3x plus 5 times x minus 2, which means x equals negative 5/3 or 2, just like it did in the last case, and our two solutions are negative 5/3, 7/9, and 2/2. We have x minus y equals 11, xy plus 28 equals 0. What method would you prefer to use here, elimination or substitution? You have no elimination option. Okay, you don't have any y terms that are like or x terms that are like. We have to use substitution. So would you rather solve the top or bottom equation for x or y? Yeah, by all means, let's solve the top one for x. X equals 11 plus y. Then we'll substitute that value in right down here. We have not x anymore. Instead, we have 11 plus y times y plus 28 equals 0. (11y plus y squared plus 28 equals 0. And that means y squared plus 11y plus 28 equals 0. How do you want to solve? Let's factor it. That one will factor without much trouble. Again, we could use quadratic formula. A is 1, B is 11, C is 28. But we can factor that into, let's see here, y And so y equals -4 or -7. So let's find out what our ordered pairs are. When y equals -4, x equals 11 plus -4, which is 7. So one ordered pair solution is another common mistake. I see this a lot. People go through all that trouble, solve that problem, and now do what little thing wrong right here? Huh? Nope. Put them in the wrong order. Because here you got y first. Just because y is the one you found first doesn't mean it goes first in the parentheses. Make sure that you put them in the order x, y. So this should be 7, -4. X value corresponding y value. Very common to, just because you got y first, think, all right, that's the first one, -4, 7. Okay, so there's one. When y equals -7, we have x equals 11 plus a -7, and we get 4. So the second ordered pair is 4, -7. And so there's our two solutions. I'm just going to give you a couple of minutes to do what you can with that. X squared plus 4y equals 6. 3x minus 2y equals -7. I chose to eliminate the y's. Did anybody choose substitution or not? Elimination works out really nice because we only need to modify the one equation. Multiply the bottom equation by 2, it becomes 6x minus 4y equals -14. Now we can combine x squared plus 6x, the y's cancel, equals -8. X squared plus 6x equals -8 when we combine them. We all right up to there? Does that look okay? Okay. Then shift that 8 over and we get a quadratic. X squared plus 6x plus 8 equals 0, which factors into x plus 4 times x plus 2 equals 0, which means x equals -4 or -2. And we've got our half of our two solutions. Look all right up to there? Well, then let's finish it up. Then we need to go back and say when x equals, let's take the first one, when x equals -4. Now we got to choose one of these to plug it back into. Let's just use the bottom one since it's linear. We're going to have 3 times -4 minus 2 times y equals -7. That's going to be -12. So if we add -12 to both sides, add 12 to both sides, we're going to have -2y equals -5. Sorry, I missed something there. That was plus 12, not plus 2. Plus 12, and that equals +5. So then y equals -5 halves. And so one solution is -4, -5 halves. When x equals -2, we'd go through the same process, and we'll find that y equals 1/2. So we've got -2, 1/2, and there's our two solutions. And we're done. We got them both. So, they're nonlinear. We really don't have to do anything differently. You just have to be a little bit careful if you use the elimination method not to eliminate common terms. And if there's more than one solution, we'll end up with a quadratic.